Welcome to my reflective breakdown of Knockout, a fast-paced top-down arena brawler. To ensure the game could handle complex multiplayer states, I built the core architecture around a centralized state machine, managed by the round lifecycle manager. This seamlessly transitions the server state from active gameplay to sudden death and into the power-up selection screen. Scalability and modularity were at the forefront of my design. Rather than having objects constantly pull one another in an update loop, which causes significant performance bottlenecks, I implemented an event-driven architecture utilizing the observer pattern. I achieved this using scriptable object channels to act as mediums between the broadcasters and listeners. For example, the multiplayer camera manager simply listens to the player camera channel SO to update its Cinemachine target group, without ever needing tightly coupled direct references to the player prefabs. This completely decouples the system. For the game's buff system, I utilized the strategy pattern to encapsulate behaviors into interchangeable classes. Using power-up definition scriptable objects as data containers allow designers to easily tweak values like scale multipliers or bonus health directly in the editor. This data-driven approach separates the design balancing from runtime execution logic, preventing a rigid code base bloated with conditional statements. For future improvements regarding code structure, I would expand my use of object pooling. Currently, I have successfully implemented an object pool for the audio manager to keep instantiations and destruction minimal. However, during heavy combat, projectiles are instantiated and destroyed frequently. Expanding pooling to projectiles and particle effects would significantly optimize memory allocation. Additionally, I built the interface using UI Toolkit, leveraging its UI document structure to keep UI logic entirely separated from game logic, further adhering to modular design principles. Moving on to multiplayer systems, I utilized Unity netcode for game objects with a strict server authoritative model. This approach is fair and intrinsically prevents client-side cheating. Gameplay actions such as dealing damage and validating blocks are handled via server RPCs, while visual auditory feedback are broadcast back to the clients using client RPCs and network variable callbacks. For instance, the network health component broadcasts on health changed events locally, allowing the UI to react instantly without tightly coupled logic. To increase the skill ceiling without bloating the control scheme, I focused on multiplicative mechanic design, which is where you make single mechanics serve multiple purposes. A standard block mitigates damage, but with the parry power up, players who time their blows correctly release a shockwave with severe knockback, transforming a defensive reflex into an offensive attack. Similarly, projectiles are inherently offensive. However, if two bullets collide, a check in network projectile compares their sizes. Equal sized bullets cancel each other out, but if a player has a power up that modifies their bullet size, the larger projectile destroys the incoming projectile, which is smaller, and carries on. This shifts shooting from single DPS into an active shielding tactic. When a player dies, they aren't removed from the experience. Inspired by games like Among Us, dead players become ghosts. The ghost spectator mode is essentially grants them full movement freedom, keeping players engaged with the match rather than just watching a static camera feed. They are able to traverse the full map, including tiles that has been destroyed. Reflecting on the multiplayer mechanics, I recognize areas for vital future improvement. First, to handle the heavy performance hit when dozens of modified projectiles are fired, I plan to migrate the projectile system to Unity's Entity Component System, or ECS and DOTS. This data-oriented approach would handle massive amounts of bullet physics drastically better than game objects. Furthermore, while the server authoritative netcode is secure, it can feel sluggish on higher latencies. Implementing client-side prediction and server reconciliation for movement would make the controls feel instantly responsive for the local player. Gameplay wise, having players being able to affect the tiles themselves whilst the round itself is going can and would make the physics of the game feel more believable, and the ghost spectators having some degree of interactability, whether it be like the ghosts on ghosts, like the ghosts just interacting with themselves, or the players, like the ghosts being able to interact with the players, would definitely make the game more enjoyable for players who are not in the active round. Finally, let's discuss the player experience, balance, and the visuals. Knockout utilizes a vibrant, toon-shaded aesthetic to maintain a fun, readable environment amidst the chaos. The arena itself is designed as a dynamic hazard. Over time, outer floor tiles systematically fall away, pushing players inwards. Much like the storm mechanic in Fortnite, this is essential for forcing constant combat scenarios. Without this, players could easily enter a stalemate or camp, ruining the intended fast-paced flow of the game. To maintain a balanced flow across multiple rounds, the game relies heavily on its power-up phase. Stalemates or dominating streaks can cause player frustration. Referencing the design philosophy of the game rounds, these power-ups are not drip-fed as minor stat buffs like single-player games, but rather they are highly potent, game-changing abilities acting as a catch-up mechanic. So when a player is defeated, they choose a power-up to upgrade their character, effectively leveling the playing field for the next round and forcing the winning player to adapt to new threats. For example, the Poison Cloud power-up leaves a lingering damage over time volume. While this may just seem like a simple concept at its core, on a shrinking map, it can be advantageous for players to intentionally misdirect hits to place these clouds as strategic choke points, and which herds the opponents into hazards or restricting their movement in general. The final piece of sensory information to improve the game feel is the audio. The sound effects in game follows the platformer art style with exaggerated hit effects. The music in Knockout operates on a dynamic, state-driven stem system that crossfades seamlessly to match the current phase of gameplay. At startup, the music manager initializes dedicated audio sources for every distinct game state, such as the menu, loading, active game, and power-up selection, and plays all of these tracks simultaneously in the background at zero volume. The system relies on a decoupled scriptable object event channel, which will be the music channel SO, to listen for phase changes broadcasted by the round lifecycle manager. For instance, when only 2 players remain alive, the game enters a sudden death phase, triggering a dynamic music shift to heighten the tension. Upon receiving state change event, a coroutine smoothly crossfades the audio by interpolating the new track's volume up to the player's master music setting, while simultaneously fading all other active stems down to 0, ensuring an uninterrupted musical flow. Here is a demonstration of the system that I have built. Reflecting on the overall balance and experience, the integration of these systems successfully create intense, highly volatile rounds. However, future development would focus on expanding visual feedback. While the UI toolkit setup is highly responsive, adding more localized screen shake, hit stop frames during melee impacts, and clearer telegraphing for the hex tiles are about when they are about to drop would drastically improve the game feel. Adding a more varied set of audio for the death and block, potentially the power ups, like the individual interactions within the power ups, can add a level of polish. Overall, the scalable architecture and data driven design means Knockout is perfectly positioned to have these features iterated upon seamlessly.